world without language, communication in both our personal and professional lives would be profoundly different. Society as we know it could not exist. Language is an ability that comes so naturally to us that we mostly take it for granted. We tend to only consider its impact and its complexity when something goes wrong. For example, when an elderly relative has a stroke and has difficulty speaking, or when a child struggles to read and is diagnosed with dyslexia, or when we find it difficult to learn a foreign language. In our study, we examined whether, in brain terms, natural language processing in context can be traced back to a very fundamental mechanism of information processing in the brain. Cognitive neuroscience research over the past 20 years has revealed that the human brain is essentially a prediction machine. This is important as it allows us to interact with the world around us. For example, think about action planning and motor control. If I want to carry out a very simple movement, such as reaching out and picking up a bottle of water, my brain does two things in parallel. One, it sets up the required motor program for the action, and two, it computes what the world would be like if the action were carried out successfully. If there is a mismatch, for example, if the bottle is slipping away and I don't get the expected tactile feedback, my brain can use this to correct the motor program in an instant. There is a brain signature of this predictive coding. Brain activity to the same sensory input differs depending on whether it is predicted or not. There is essentially a deactivation of relevant brain areas when the stimulus is predicted as opposed to when it is not. Our study showed that this aspect of information processing in the brain is also operative when we understand complex linguistic input. In our research, we had 20 young healthy adults listen to short stories while they were lying in an MRI scanner, a machine which allows us to measure activity changes in the brain during a certain task. Within each story, we introduced certain characters, for example an engineer, and then mentioned this character again later in the story. We then compared changes in brain activity when the characters were mentioned again, depending on how predictable their re-mention was. When we did this, we saw a deactivation of a range of regions in the brain for more predicted versus less predicted re-mentions of a story character. One of the main regions showing this pattern was the inferior parietal lobe, a part of the brain which is known to be important in integrating information from a wide range of sources such as processing of language in context. This study is the first to show that prediction, as a fundamental mechanism of information processing in the brain, is also in operation when we process language. We hope that this research will also eventually allow us to address real-world challenges such as language rehabilitation after brain injury or how to optimise foreign language learning.